So, in the world of AI agents, it's really important to know how much money or how many tokens each agent is using, because it's not like regular software code that runs stably and consistently. There are no unpredictable results. With AI agents, it's a bit different, and you know that. That is, you need to know how much each agent is spending, because they can hallucinate. They can behave unpredictably. That's why I created a special workflow that helps monitor expenses. Let's take a look. Alright, let me show you how it works. I'll type, for example, the weather in London. In London. And so it starts up, uses OpenRouter and tools like Tabl, tables, and then it also logs the actual expenses, which we'll look at a bit later, and it gives a response. And here, in this case, we see the answer. Alright, let's see what it's logging here. So in this case, we see a timestamp, right? That's the time and date, the name of the workflow that logged and added this entry. Also, the agent's input, meaning what data was received as input, and what data was produced as output. The error message is empty, accordingly, because no error occurred. A bit later, we'll take a look at what it looks like when an error does occur. Pay attention to the actions column. An action is a tool, right, that the agent used. That is, agents can hallucinate, get confused, or use different tools multiple times. Here will be visible. So, when you have a usage database for an agent, you'll be able to analyze and understand whether the agent is hallucinating, whether it's using the right tools depending on the input data. We also clearly see here the tokens that were spent on the input prompt, and the tokens that were subsequently spent on the output, providing a detailed breakdown. In other words, if you don't know, the cost of using an LLM model consists of how large the prompt was on input and the size of the response you get as output. If you're not familiar with this, let me know in the comments and we'll cover this topic in more detail again. So, this is the total number of tokens and the amount in dollar equivalent, depending on which model you used. And this way, you can have a very large database, and then, depending on how many agents you use, you can analyze their expenses, which is very important because some agents can hallucinate. And in this way, you'll clearly see things like, say, you switch to a better model, right? And by using this model, let's say for a week, you'll be able to understand how much more expensive it is for you, how relevant the answers are, or maybe how much cheaper it is for you. And maybe the answers will be better. So this kind of logging is a very, very useful thing. And let's get back to the main workflow. Let's take a look here at how exactly this workflow, log expenses, that I created is structured. So what does log expenses actually consist of? It's a trigger node. If else, here we're just checking if this parameter exists, which means some kind of error occurred. I'll show you how it works a bit later. If there's an error, then we follow a separate branch. If there's no error, then I have carefully written a piece of code here that precisely takes the tokens spent from the agent's comprehensive response. This code then meticulously formulates, well, it effectively creates a very special and specific structure and subsequently passes it along for thorough logging directly into our designated Google Sheets. Everything is pretty simple. It's all included in this node. Alright, so let's run it again and say, turn it off and see how the error gets logged. The prompt will be exactly the same. Let me copy and paste it. Look, the agent worked. It returned with an error and passed it to log expenses. And we got an error saying that the chat model subnode must be connected and enabled. Okay, now let's move on and check the logs so we can see that the error has been recorded. How did we know it was an error? It's because the error message isn't empty. The error is displayed here. And accordingly, this didn't cost us anything in tokens, because no request was sent to the LLM. But of course, for this to work for you, pay attention. I added return intermediate steps here. In other words, I asked the AI agent node to return the intermediate steps. And so here, if we go into the logging, well, we won't actually see it right now, right? So let's reconnect and run it again. Running. It responds, logs. Okay, all the intermediate steps are fully enabled. And here, if we look closely, it returns a very detailed data structure showing precisely how it worked, how it executed, in what specific sequence. This node right here, the one I have the code for, is exactly what handles this. It parses all the things we need, total tokens, prompt tokens, cost into a special object, sums them up, and then returns them to us. That's exactly what this node does. So the agent starts returning if we go to the logs, right? So right here in N8N, we can actually go through the various and distinct steps and see precisely what was input, what was output, and how frequently the LLM model was called. I truly hope you thoroughly enjoyed this video presentation. Like, subscribe to the channel, leave comments, and join the Telegram group. There have been a lot of discussions happening there lately. People share their problems, and we try to solve them. I help out, the team helps, and so do people who join in. So, a community is forming that's interested in N8N. So subscribe and share your thoughts in the comments. Also, just a reminder, I have a course on N8N. The link is in the description. I'll also leave it in a pinned comment. If you haven't heard about it yet, check it out. It should be a really interesting course. You can still influence it. If you sign up for the waitlist and take the survey, which will actually help shape the course structure, since I haven't written it yet. Anyway, I'll see you in the next video.